Hello students, welcome to the unit number 8 of this course Electromagnetic Theory 2 and Theory of Relativity. This is part B, Theory of Relativity. The name of the unit is Relativistic Kinematics and the name of the module is Derivation of the Lorentz transformation equations and derivation of its consequences such as length contraction and time dilation part 2. I am Yatin Desai, Assistant Professor in Physics, Parvatibai Chowgale College, Margao, Goa. Outline of this module: derivation of length contraction as a consequence of Lorentz transformation equations. Learning outcomes: at the end of this module, you will be able to derive inverse Lorentz transformation equations and you will be able to comprehend length contraction as a consequence of Lorentz transformation equations. Let us first obtain inverse Lorentz transformation equations from the Lorentz transformation equation. Lorentz transformation equations are given by x dash equal to x minus vt divided by square root of 1 minus v square by c square, equation number 1, y dash equal to y, equation number 2, z dash equal to z, equation number 3, and t dash is given as t minus v by c square times x divided by square root of 1 minus v square by c square. This is equation number 4. Now consider equation number 1, that is x dash equal to x minus vt divided by square root of 1 minus v square by c square. We cross multiply this, and on cross multiplying we get x dash times square root of 1 minus v square by c square equal to x minus vt. Taking this minus vt on the other side, we get x equal to x dash times root of 1 minus v square by c square plus vt. This is equation number 5. We will come to this equation number 5 later. Now consider equation number 4, which was given as t dash equal to t minus v by c square times x divided by square root of 1 minus v square by c square. Again cross multiplying this equation, we get t square equal to t square times square root of 1 minus v square by c square equals t minus v by c square x. Now we substitute this t. Okay, we write t as t dash equal to square root of 1 minus v square by c square plus vx by c square. And now we substitute this t in equation number 5 and get the inverse transformation for x. So on writing that, we get x equal to x dash 1 minus v square by c square plus v times t. Okay, so t is replaced from this by this equation, which is t dash times square root of 1 minus v square by c square plus v square x by c square. V square x by c square, if you take it on the other side and combine it with this term on the left hand side, we write it as x times 1 minus v square by c square equal to, combine these two terms by taking square root of 1 minus v square by c square outside this bracket. This bracket will have v x dash plus vt dash. Therefore, on taking this or dividing this bracket on the right hand side, we get x equal to x dash plus vt dash divided by square root of 1 minus v square by c square. This is the inverse transformation for x. Y dash is y, z dash is z, and now let us look at t equation. T was given as t equal to t dash square root of 1 minus v square by c square plus vx by c square. And here now let us substitute x as given by equation number 5. So t is equal to t dash square root of 1 minus v square by c square, v by c square, and this is what is x as given by equation number 5, which is x dash times square root of 1 minus v square by c square plus vc. Now combine this t term onto the other side, but it is multiplied with v by c square and v, so it is v square by c square. When you take it on the other side, it will be minus v square by c square, t is taken out and we get this bracket as 1 minus v square by c square. Square root of 1 minus v square by c square is taken out and we get in the bracket t dash plus vx dash by c square. Therefore, on dividing this bracket onto the right hand side, we get t as t dash plus vx dash by c square as square root of 1 minus v square by c square divided by 1 minus v square by c square. That 1 minus v square by c square is the product of two square roots, and we can cancel one of the square roots from the numerator and the denominator, and we get t as t dash plus vx dash by c square divided by square root of 1 minus v square by c square. We call that as equation number 9. So we have now all our inverse Lorentz transformations as given by x equal to x dash plus vt dash divided by square root of 1 minus v square by c square, y equal to y dash, z equal to z dash, and t equal to t dash plus vx dash by c square divided by square root of 1 minus v square by c square. Now, let us look at some consequences of Lorentz transformation equations. The first consequence is length contraction. The statement is a length of an object is measured to be greatest when it is at rest relative to an observer. And when it moves relative to an observer, its measured length is contracted by a factor square root of 1 minus v square by c square in the direction of motion, whereas its length perpendicular to the direction of motion remains unaffected. Now let us prove this statement. To prove this statement, let us imagine a rod lying at rest along x dash axis of x dash frame. So this dash dash frame and this the rod. The endpoints of this rod are measured to be x2 dash and x1 dash. So the difference between the endpoints is the length at rest, and that length at rest we call it as L dash. Now this rod is in the x dash frame and the frame is moving. So to measure the length of the rod from the S frame observer, from whom that rod is moving in the along the x direction with the relative speed v, to do that we have to apply the Lorentz transformations, because the endpoints x2 dash and x1 dash when observed from S frame will undergo the Lorentz transformation. Therefore, we write that x1 dash as x1 minus vt1 divided by square root of 1 minus v square by c square, and x2 dash similarly we get it as x2 minus vt2 divided by square root of 1 minus v square by c square. If you take the difference between two endpoints, so x2 dash minus x1 dash, we will get, if you subtract this equation from this, it will be x2 minus x1 divided by square root of 1 minus v square by c square, minus, if you write here, it will be v t2 minus t1 divided by square root of 1 minus v square by c square. This x2 dash minus x1 dash is L dash, which is the length of the rod in S dash frame, which we call the proper length, because that is the length of the rod when it is at rest, measured at rest. And x2 minus x1 is called as L, which is the length of the rod as measured in the S frame, and it is called the improper length. So we write that L dash equal to L divided by square root of 1 minus v square by c square, with t1 equal to t2, because endpoints are to be measured at the same time. We cannot measure it at two different times. Otherwise, the length would have been larger. Therefore, L is L dash times square root of 1 minus v square by c square. And writing that v by c as beta, we write that L equal to L dash times square root of 1 minus beta square. This is like a contraction factor. Thus, the measured length of the rod is contracted by a factor square root of 1 minus beta square from its rest length L dash, but y equal to y dash and z equal to z dash. These are the references for this module. Thank you.